this chapter, we will be studying factoring. And to begin, we will review the factoring you learned in Math 10. Starting with the removal of the greatest common factor.
All right, welcome. So we're going to start talking about factoring. This is important. The majority of this course is going to be working with quadratic functions, quadratic equations and whatnot. And you're going to find that factoring becomes an indispensable tool when you are basically analyzing quadratics. Okay, and this is something you're going to use throughout this course. This is a skill that you need to start to get a fair bit of proficiency in. Okay, and so we're going to go back and review this at the beginning of this course so that we give you the tools that you need throughout the course here. And to start off with, the first thing that we're going to talk about is greatest common factors. Okay, so, and you've done this before, you did this in Math 10, but we're going back to it again, just to remind you of some of the things that you may have forgotten here. So first of all, what you're going to do is you're going to check and see if there's a number that is a factor of every term. Okay, so we're going to look at the coefficients first, and remember how this works here. Okay, if I've got, for example, let's say 2 times x plus 3, remember that that 2, when you multiply that out, gets distributed through. So that becomes 2 times x plus 3 times 2 is 6. Now, when we're factoring, we're starting here and we want to go backwards. Now, what we notice here is that there's a 2 that's a factor of this term, okay, 2 times x. And I notice that in 6, there's also a 2 that's here. So a 2 has been multiplied through both of these terms. Now, I can write it like this, and this is how you're going to get the questions asked. But what we want to do is write this as if it's being distributed amongst other terms. We want to separate out the piece that's being distributed from the piece that it's being distributed over. So instead of having the 2 multiplied here, the 2 multiplied here, I'm going to put the 2 out front, a single 2. Okay, and when I put brackets here, I'm saying that whatever's inside here is going to get multiplied by that 2. So in this first case, it was the x multiplied by 2. In this second case, it was the 3. And that's what we mean. We're going to take and find whatever that factor is that's common to those terms, and we're going to write it out front. Now, there's some other things that happen. Whoops, sorry, wrong way. There's some other things you need to consider here. This says here if the first number is a fraction, that really doesn't have to be the first number. If you see a fraction in the coefficient, okay, basically if you've got a number in the denominator, then we are going to consider that a common factor and we're going to factor that out. We're going to be pretty consistent about that. This is something that's going to come up again later on in a course down the road, and this is going to be a really important thing for you to do here. Okay, so for example, if you have let's say 1/3 x plus 5. Okay, let me zoom in a little bit on that. Whoops, I keep going the wrong way there. Let's see, you've got 1/3 x plus 5. We are going to assume, because of that fraction, that 1/3 is common to both of those. We're going to pull that out. Now, this does cause problems, though. I don't deny that. Okay, as soon as we start working with fractions, there's going to be a little bit of confusion here. But I take that out, and actually that makes sense. 1/3 times x will be 1/3 x. But okay, bear in mind that when I pull this out, like when I went up here and I took from that 6 to that 3 there, it was because I divided out the 2. I knew that the 2 had been distributed to both terms, but to go backwards I had to divide that out. Here, if I'm going to say that 1/3 is common to both these terms, I have to divide that out of 5. So what is 5 divided by 1/3? Okay, now hear what I said there. I didn't say what is 5 divided by 3. I said what is 5 divided by 1/3. Okay, so 5 divided by 1/3. When you divide by a fraction, remember that's the same as multiplying by the reciprocal. So 5 divided by 1/3 is the same as 5 multiplied by 3 over 1, which is in fact, 15. Okay, I didn't say 5 divided into thirds. I said 5 divided by 1/3. Okay, and you got to be really, really clear on that. Okay, now another thing you need to worry about here is that if there's a negative on that first term. Now this is specifically when we say first number here. In this case here, the assumption here is that this is in standard form. That you are starting with the highest power first, the largest degree power first. Then what we're going to do is we're going to factor out that negative. Honestly, it just looks better. It cleans things up. It makes it a little bit easier to work with. Now, if you've got common variables, then what we do here is we look at their exponents, and we're always going to factor out, okay, write the power out front here that has the smallest exponent, the smallest, basically the lowest degree power, okay? And then finally, if we run into some binomial factors, then we will write those out front here. And this is, you're going to recognize that specifically from grouping that you would have done in Math 10. You'll see that kind of that pattern pop up again. All right, let's have a look at some examples. Okay, so we're going to just do some common factoring here. We've got two terms here. Look at their coefficients first. I've got 25 and 75 here. Now, I can see right away that 5 has to be a factor. These are both going to be divisible by 5. But actually, we can go a little bit further than that. 25 is also going to be a factor. 25 is a factor of 25 and a factor of 75. So 25 has been multiplied by through. Now, if I didn't get the largest common factor here, I'm going to need to try to find it. But if I didn't get it to start off with, what I'll do here is at the end, I'll just investigate the expression that I have and see if there is anything that's still common to the terms that I'm left with. I'll show you in a second what I mean by that. Now notice I've also got an x in both terms. The smallest exponent on the x is the 1 though. Okay, here's 2, here's 1, so we're going to take out the 1. That 1x there. Now what am I left with? Bearing in mind that the process here is essentially division. So 25x squared, if you divide out this piece right here that I said was common, 25x squared divided by 25x is just going to be x. Positive 75x divided by 25x is just going to be 3. Okay, the x's will cancel. 75 divided by 25 is going to be 3. So here we go. 25x multiplied by x plus 3. There's nothing common to these two terms, so I'm done. Okay, that's as far as I would go. And that's what I'm referring to. If I only took out the 5, then I would have been left with a 5, and what would I have been left with? That would have been a 15? Yeah. And then there would have been a common factor of 5 to those two that I would have taken that out as well. Let's take a look at this one. We've got 3 terms here. Okay, let's look at the coefficients. 3, negative 15, and 9. Okay, well there's obviously a common factor of 3 to all of those. Okay, those are nice small numbers, easy to work with. I've got an x and a y in all 3 of those terms. Now let's look at the x here. It's cubed to the 4th and to the 5th here. Okay, well the smallest exponent is the cubed. Okay, and the reason I use the smallest exponent is because I can take an x cubed out of here, out of here, out of here. But I couldn't take, for example, an x fifth out of here. I don't have enough x's. So the only one that could possibly be common would be the smallest power here. For the y, it's going to be 2, 1, 2, so it's going to be just the 1 there. And now 3x cubed y squared divided by 3x cubed y. Well, 3 divided by 3 is 1. X cubed divided by x cubed is 1. Y squared divided by y is just going to be a single y left over. And if you multiply that by the y, you will regain that first term. Negative 15 divided by 3 is negative 5. X to the 4th divided by x cubed will give me an x. And then y divided by y is 1. And I don't really need to write that. 9 divided by 3 is going to be positive 3. X to the 5th divided by x cubed will give me x squared. And then y squared divided by y is y to the power of 1. And again, I don't need to write the 1 there. There you go. Now I'm going to take a quick look here. Is there anything common in the coefficients? No. Anything common with the variables? No. So that's about as far as I can take it for right now. Good. Let's look at this one. Look at the coefficients, 2 and 4. Okay, they both have a common factor of 2, but my coefficient over here is 1 in front of that final little a there sitting all by itself. Because there's a 2 that's not, a 2 is not common to all 3 terms, there is nothing common in terms of the coefficients. Okay, I got to leave it as 2, 4, and 1. With the variables, I've got an a. Okay, good. I have an a in every term. It's squared here. It's to the power of 1 to the power of 1, so I can only take out a 1. And with the b, I've only got a b in those 2 terms. So b is not a common factor. It's not in every term here. So that's the best that I can do. And when I divide out an a, I will be left with 2ab in that first term. In the second term, I will be left with 4b cubed. And then a divided by a is 1, so I don't need to write that. Now over here, a divided by a in this last term is 1, but I do need to write that because there's nothing else. Okay? There is nothing else left over there. So basically to hold that place right there, I need to put that 1. And if I multiply that a through, you'll see that I go right back to that original expression. If I don't put the 1 there, I've only got 2 terms inside this set of parentheses, and when I expand that out, I'll still only be with 2 terms. So that, if I don't write that plus 1 here, these two are not exactly the same. I've actually gotten rid of that last little a there. Okay, you can always check to see if you're doing it right by multiplying back out, by distributing basically the factor that you've pulled out here. If you don't go back to the original expression, then something's gone wrong. Okay, let's keep going. Okay, now notice in this case right here, we do have this obvious binomial factor. We'll get to that in a second. Look at the coefficients here, 10 and 7. Okay, there's nothing common there. Okay, let's look at the variables here. The x is only in this first term, so it's not common. The y is in both terms, but because it's within the parentheses here, I actually can't think of the y by itself. I actually got to think of it as grouped together with that minus 3. Okay, the parentheses are that strong. They hold those together. So really what I'm saying is I've got this common binomial factor y minus 3. So I'm going to pull that out. It was multiplied by 10x in that first term. And in the second term, it was multiplied by 7. So essentially what I'm looking at here is I see that the y minus 3 was distributed to this term right here, the 10x, and then it was distributed to the 7. Okay, so there you go. Over here, again, I got the 2 terms here, so I'm going to look at the coefficients. I see a 1 and a negative 4. Okay, well, there's nothing common there. I've got an x here outside the parentheses. I'm going to look outside the parentheses first. And then, okay, well, there's no x there. So the x is not common. Now I look at the parentheses here, and I've got an x minus 5. Okay, and a 5 minus x. Well, those aren't actually the same. They need to be identical in order to factor something out here. But when I look at this binomial factor right here, just notice that it's not pretty. There should be something about that you notice that, that doesn't quite look right. This looks pretty. This little binomial here is written in standard form, largest degree first and then down to smallest degree. So I'm going to do that over here. I'm just going to change the order that this second binomial factor here is written in. Now, if I move that x forward, I have to take the negative with it. Okay? It would help me to think of this as positive plus minus x in this particular case here. So when I switch the order, it's negative x plus 5. Okay, well, those are still not the same. Okay, because here the x is positive, here the x is negative. But at least this is in a nice order. Now, notice that all of the signs are the same, are different here, I should say. This is positive x, this is negative 5, this is negative x, this is positive 5. What I can do in a situation like this is I can simply say, okay, I'm going to pull a negative out of that. I'm going to factor out that negative. I'm going to yank it out here. Now there's a negative 4 out front. So when I pull out that negative x from there, that's going to make this a positive 4. Okay, because it's negative right now. I'll pull out another negative. That'll make it positive. And that'll change all of the signs inside this binomial. Now that x minus 5 is common to both of those terms. Now I can yank that out. And just looking at what I've got here, it was multiplied by x in this first term, and it was multiplied by positive 4 in the second term. Now bear in mind, when I write it like this, this x minus 5 is still being multiplied by x and still being multiplied by 4. When I put the parentheses here, it implies that it's being distributed through. So that's just another way of writing it. I hope that's clear. Sometimes it's less clear when you start pulling these into 2 separate binomials, but it's still exactly what I need it to be here. Okay, down here. Okay, now there's a fair bit going on in this one. To start off with, let's look at the coefficients here. I've got a 5 and a 20. Okay, that's nice because there's a common 5 there. There's an a here and an a squared here. Okay, that's good. So I'm going to pull out an a to the 1. That'll be the smallest exponent there. And now I've got a b minus 2 squared. And okay, here's a 2 minus b. Well, that's not what I need it to be. The order is wrong. This should be negative b plus 2. At the very least, it should be negative b plus 2. But then the signs aren't the same. So I'm going to change that. Now, so I'm going to put a square bracket here because I'm not quite done factoring. I'm going to typically use the square brackets to indicate that there might be a little bit more for me to do here. So the very first thing I did was took out the 5a. That left me here with a b minus 2 squared plus, that was 4a, and then negative b plus 2, because I changed the order there. Now, the binomials here are not the same, so I'm going to take out the negative in that second term. So again, I'm going to put the square brackets here because I'm not convinced that I'm done yet. And if I take out the negative, it's going to change the sign of that coefficient. This is going to be left with b minus 2, still all in square brackets. But now there is a common b minus 2. Now notice there are two factors of them here, just one here. So that same rule that applied with the a. When I took out the a here, so this was a to the 1, this was a squared, so I took out a to the 1. b minus 2, b minus 2. I mean, I don't know what b is, so I don't know what b minus 2 is. It's just as much of an unknown as b. So because this is b minus 2 to the 1, that's what I'm going to take out. So this is going to be 5a, and now I don't need the square brackets anymore because I know exactly what's going on here. This is going to be b minus 2 to the 1. I took that out. I'm left with a b minus 2 left over here in this first term, in parentheses, and I'm left with a minus 4a at the end here. That was what I took out of this term. Sometimes this is a little awkward to work with because you'll see that you're left with this. There's more than just the two terms here, but that's all it is. And now what I would do in this particular case here is I would drop these parentheses so that I've got 5a times b minus 2 multiplied by b minus 2 minus 4a. And notice that, and the reason I can do that is because there's nothing being multiplied in front, like within this set of brackets here, there's nothing being multiplied out front. I can just drop the parentheses. They weren't really doing anything for me at this point anyway. Prior to this point here, it was telling me that b minus 2 is one expression here. But now that I'm at this point right here where it's just b minus 2 minus 4a, the parentheses aren't really doing anything. Now at the very least what I could do here, everybody, is I could make this a little prettier. b minus 2 minus 4a really should be written, if I was to write it in standard form, it would be minus 4a plus b minus 2. Okay, alphabetic in order of decreasing power. Now there's one last thing, and I know you're probably wondering, when is this question ever going to end? But bear with me here. There are just some things here that are going to help out a little bit here. That little negative in front, it just doesn't look very good. It's not wrong, it just doesn't look very good. Just like here, there's nothing wrong with b minus 2 minus 4a. It's not incorrect. It doesn't look good. I changed the order, it looks better. If I take and factor that negative out of the whole thing, now I'm going to just bring it right to the front. This is all multiplied together anyway, so order doesn't matter. So I'm just going to move that negative right up to the front. This becomes 4a, change the sign minus b, change the sign plus 2. That looks better. It looks cleaner. It's going to be easier to work with when it looks better. Okay? Let's move on to the next one. That was a long one. Okay. Now here, notice that I'm seeing a fraction here. I'm going to take out the fraction. That's just going to be an automatic. Okay? And then between the two terms here, I've got an a squared here and an a cubed here, which means I'm going to take out an a cubed. Now, I have to divide out the 1/3. Whoops, sorry, whoa, I said cubed. I meant squared. Wow, glad I caught that before I went too far here. I have to factor out the 1/3, and actually we've done almost exactly this, this example earlier here. 5 divided by 1/3, not divided in thirds, divided by a third, is going to be 15. And then that a squared divided by a squared is just going to be 1. It's going to become 1 there, so I don't have to write it. I took out the 1/3, but I was left with a negative 1. And then the a cubed divided by a squared is simply going to be a. Now, that is correct. There's nothing wrong with that, but it's written in kind of an awkward little order there. So I'm going to fix the order a little bit. I'm going to make this 1/3 a squared. I'm going to change the order, but I'm going to assume that this is positive plus a minus a, so I'm going to make this negative a plus 15. That's a little bit of a cheat. Order doesn't matter with addition, but it does matter with subtraction. However, I can get around that if instead of thinking of this as subtraction, I think of it as plus and negative. If I just keep that negative with the a there, then I can play with the order a little bit. And now finally I will factor that negative out because it looks better. It just looks better if those terms don't start with a negative. And you'll find out later on that in fact it is easier to factor, easier to manipulate if the negative isn't inside there. Okay, this question right here, same thing. I've got another fraction involved in here, but I've also got a negative there. So actually, because there's a negative common to both, I will take out the negative 1/7. And then I'm seeing an x here and an x here. The smallest exponent is x to the 1, so I'll take that out. Now, out of my first term, when I divide that all out, I'm just simply going to be left with an x there. Negative divided by a negative is positive, so this will be positive. Now, these numbers were chosen specifically to see if you're paying attention to this. This is going to be 21 divided by 1/7, not divided into sevenths, but divided by 1/7. And when you divide by 1/7, you have to multiply by the reciprocal. This is going to end up being 147. Okay? And then I took out the x, and so there we go. And actually that is written nicely. There's really nothing I would do to change that. Just bear in mind what just happened right there. I divided by a 7th, which means I had to multiply by the reciprocal. I didn't divide by 7 by 1/7. Dividing by 7, this question would have looked like this. If this had been negative 7x squared minus 21x, then I would have divided out that negative 7. I would have taken out a negative 7x, and this would have become x plus 3, which is what I think a lot of people are going to want to try to do here. You really have to be conscious of what it is that you're dividing out and how that works. Okay, if I was to stand behind you and look at you while you did this, okay, and if you did this wrong with the fraction here, in most cases all I have to do is kind of shake my head. I wouldn't even have to point out what the issue was, and most of you would look at it and say, oh yeah, you know what you got to do. The trick is making sure you do it consistently. Okay, let's just do a couple more here. So up here, again, I'm dealing with a fraction, and it's negative here. I'm going to take out the negative. Okay, so I'll take out the negative 1/5. I've got x's and y's in both terms. I don't know what the exponents should be yet, but I know that they're going to be an x and a y out front. This is x to the 4th, x cubed, so we'll make that x cubed. Y cubed and y, so I'll take out a y to the 1 there. Now, in this particular case here, negative 1/5 divided by negative 1/5 will be 1. X to the 4th divided by x cubed is going to be x. Y cubed divided by y will be y squared. Over here, okay, 15 divided by negative 1/5. Remember, I'm dividing by a fraction here. Okay, so when you do that, that's going to be 15 basically multiplied by 5. Okay, because you have to multiply by the reciprocal, and so 15. Well, this is going to be negative here too, because I took out a negative. That is going to be 75. And then we got y divided by y is just going to be the 1. X cubed divided by x cubed is going to be 1. And so there we go. I know that takes a little bit of effort getting used to, but believe me, it'd be worth it in the end to just get comfortable with the way that works. Let's take a look at this last one here. Again, I see a 1/2 there. I am going to take out the 1/2 for sure. I've got an x squared and an x. The smallest exponent on the x is 1, so I'll take that out here. 1/2 x squared divided by 1/2 x. The 1/2 divided by 1/2 will be 1. X squared divided by x is just going to give me an x there. And remember, once again, this is not 3 divided by 2. It's negative 3 divided by half. When you divide by a half, it's the same as multiplying by 2. So that negative 3 will become negative 6. Then x divided by x is just going to be 1. And I don't need to write it because I've already got a number there or a term there. So there you go. This will become 1/2 x times x minus 6. There's a few things you got to remember as you're working through this. Just a few small rules. Okay, and they're all summarized at the beginning of this lesson here. Please take some time to practice that. Anyway, now we're going to take a quick look and try to remind you of difference of squares.
Now we will review the difference of squares factoring.
Okay, so now we're going to take a look at the factoring of a difference of squares here. And before we get into this, let's just want to identify kind of a common mistake that gets made here. Let's say that you've got x plus 3 and you square it. And actually, tell you what, let's be even more specific here because of where we're going to be going here. Let's say it was x minus 3 squared. Okay? Very, very common mistake that people make is to think that this goes to x squared, let's say minus 9, or even plus 9, because they see that there's a negative there and they gotta square that. That's not true, okay? The square here does not distribute amongst the two terms here in the binomial. It's just not the way that works. Okay, if it was multiplication, if this was x multiplied by negative 3, then yes it would. Yes it would, okay? But in this particular case here, the exponent does not distribute. Multiplication distributes across a binomial, an exponent doesn't. And in fact, what we've got here is, if we've got x minus 3 squared, that means the same thing as x minus 3 multiplied by x minus 3. Okay, and then each term here gets distributed to each term here. So x gets distributed to the x, so we get x squared, and then x to the negative 3. That takes care of the x in the first term, and then we move to the second term here. Negative 3 gets distributed to both, so we would get negative 3x, and then negative 3 times negative 3 would be positive 9. And so what we end up with here, and I'll just keep going horizontally here because I'm going to go down in a second, I would get x squared minus 6x plus 9. And it's usually that minus 6x that people forget. Now, the rule, if you want to think of it this way, that is sort of being attempted here is this one right here. Let's say you've got x minus 3 and you multiply this by x plus 3. Now, notice that I'm not squaring anything, but just watch what happens here when I multiply that through. X gets distributed to the x, so we get x squared and then 3x. And then I distribute the negative 3 through, and we get negative 3x minus 9. And now notice here that the two middle terms have the opposite sign, and so those will become 0. Positive 3x minus 3x becomes 0, and I get x squared minus 9 left over. There's the two terms that I'm looking for. That's that binomial that I was wanting from the beginning here. But I only get it when I multiply binomial conjugates together, which are the same factor, the same term, binomials here, just with opposite signs inside there. That's what I need. If I square this thing, I'm going to have that same sign twice there. Same sign twice. I'm going to have to double up that middle term. Okay? So this is what we mean by difference of squares. When you recognize that you've got a square term and we're subtracting a square term, I can rewrite that as square root minus square root multiplied by square root plus square root. Okay? Now, just a little word of advice though when you're going into this here. Always remove a common factor first if you can. Okay? Always pull that one out here. And then you want to just move ahead with your factoring there. Okay, so let's take a look at some examples. So let's just jump in. We're going to start factoring here. So notice in this first one here, I've got x cubed minus x. Now, before I do anything, I should always be looking for common factors. And I can see right now that there's an x that's common to both those terms here, a factor of x at least. So I'm going to write an x out front here, and this is cubed, this is to the power of 1, so I'm always going to take out the smallest exponent. That's going to leave me with an x squared here minus 1. And I should always check once I've pulled out a common factor just to see if there's anything else I can do here. And I notice that in this little binomial, okay, I've got perfect square term minus perfect square term. So that is going to end up being a difference of squares. And so I put square root minus the square root plus the square root, because that's the pattern, okay? Square root minus square root plus square root. Now, it doesn't really matter which order you do those two terms in. You're going to see that I'm going to frequently put the x minus 1 first. And that's because, you'll see in a bit here, that's going to be a visual cue to me in special circumstances where additional factoring might be possible. You'll see it when it pops up, and I'll point it out really quickly there. Okay, so there we go. Let's move on to the next one. 81x squared minus 16. I have two terms there. So it suggests a difference of squares. I'm looking for anything common to those two terms first, and I'm not seeing it. So I'm simply going to break this thing apart into the two terms here. The square root of 81x squared will be 9x. The square root of 16 is going to be 4. So this will be 9x minus 4. And then, because it is a difference of squares, 9x plus 4. That's all we got to do. 4x squared minus 16y to the 8th. Now, although both of the, okay, although I'm seeing two terms here with a subtraction in between, and these are both perfect squares. Now, this might be a little less obvious, but it is, okay, and I'll explain that in a second here. I still should take out what's common first, and what's common here is that factor of 4. And I will get x squared minus 4y to the 8th. Now, these are both squares, and so I've got a difference of two squares here. So the 4 stays, can't do anything about that. I'm going to get two terms here. The square root of x squared is going to be x, and I'll put that up front here. This is going to be minus, plus. The square root of 4 is 2. Now, what's the square root of y to the 8th? Now, bear in mind that when I talk about a square root, what I'm talking about here is a factor that when multiplied by itself takes me right back to this function right here, or to this expression right here. So I want some power of y that when I multiply it by itself here gets me y to the 8th. And remember that when I multiply two, oops, you can't see that. When I multiply two powers together, I add the exponents. So this is like saying I'm going to add y to the a equals y to the 8th. So essentially, this is going to be 2a's equals 8. In order for me to take the square root, all I got to do is divide that exponent by 2. And that becomes y to the 4th, y to the 4th. That's not always obvious, and sometimes people want to start taking the square root of the exponent here, but that's not what you do. When the value's in the exponent, and I can't overstate this, if it's in the exponent, you divide by 2. If it's in the coefficient, then you take the square root. Okay? And I know that people they hear me when I say that, but it doesn't always register with them what exactly I'm saying here. The coefficient I square root, the exponent I will divide by 2. Okay, let's keep going. Next one here, 27m cubed minus 12m. Okay, well, I see two terms, subtraction in between, that's a good sign. But these are not squares. So I'm going to take out what's common first. And between the 27 and the 12, it's really just a factor of 3. Between the m cubed and the m, it's just a factor of m. So when I take that out, I will end up with 9m squared minus 4. Okay, then I take a look at what I'm left with, and I notice that that is a difference of squares. So there's the 3m out front, can't do anything with that. The square root of 9m squared will be 3m. Square root of 4 is 2. So 3m minus 2, and then the second factor here will be 3m plus 2. Next, 3y to the 4th minus 75. Okay, I've got two terms, subtraction in between. These aren't exactly perfect squares, but there is a common factor of 3. So if I take that out, I get y to the 4th minus 25. Okay, now again, I recognize that y to the 4th is a perfect square because I can divide the exponent by 2. Okay, this is not a matter of me taking the square root of 4, although 4 is kind of a special number because its square root is the same as dividing by 2. And then 25 is a perfect square there, so this will become square root minus 5, square root plus 5. Now I would love to go down and break this one up because y squared is a perfect square, but 5 isn't. Okay? Now technically I could. I mean, I really could break that apart. I could make this 3y minus, well, the square root of 5 is root 5. And then I could make this y plus the square root of 5. I can't do anything with this factor over here, y squared plus 5, because it's an addition in between. And that's as simple as that expression will get here, unless I start working with complex numbers or whatnot. So that's as far as I'm going to go. I could do this. Don't. Okay? Don't go there. Don't do that. But later on down the road, you might find in a class that you might take later on here that actually, knowing that you can do this, might serve a purpose, might be helpful. Okay, let's keep going. Okay, so here we go. We have got two terms here, and we've got denominators. Let's face it, those aren't cool here. One of the things that we're going to want to do to start off with here is we want to get rid of those things. Okay, so what we're going to do here is I'm going to divide out a fraction here, and it's going to be kind of nasty here, but that's okay here. I'm going to divide out essentially the common denominator here. And because 25 and 16 have nothing in common, I'm really going to have to just multiply those together. That's going to end up being 400. Okay? So I'm going to divide out this factor of 400 here. Now, when I do that, I am going to be left with 16d squared minus 25e squared. Okay? I can verify that by simply multiplying this 1 over 400 through. If I multiply this through by 16 over 1, the 16 and the 1 get multiplied together, the 1 and the 400 get multiplied together, and when I divide, or sorry, simplify 16 over 400, I will get 1 over 25. Same thing over here. 25 over 400 will reduce down to 1 over 16. Now the way I got that, okay, is I took that 1 over 25, okay, 1 over 25, and I divided it by 1 over 400. Now, a very common mistake when people start working with fractions here is to really mishear what's going on here. I am going to take that 1/25th and I'm going to divide it by 1/400th. I am not going to divide it into 400ths. I'm dividing by 1 over 400. And when you do that, that means multiplying by the reciprocal, and when you multiply 1 over 25 by 400 over 1, you will in fact get 16. Whoops, sorry, can't see that. That's a difficult idea. Okay, most of us are not super comfortable with fractions. And so whenever you see them pop up, just take a moment, take a breath, make sure you're doing things properly here. Okay, so this is still going to be 1 over 400, but now this is a fair bit easier to break apart into its two factors here. The square root of 16d squared will be 4d, and then the square root of 25e squared will be 5e, and so then this will become 4d plus 5e. Okay, my two conjugates there. Over here, 25 minus a squared. Now, this is, you can totally factor this right now the way it is. However, if you've followed along any of the other videos that I've done here, you're going to notice that I tend to approach this by saying, look, I can factor that, but it's not pretty. I don't like the way that looks right now. I don't like the fact that that a squared is at the end here. Standard form says that I should have this in order of decreasing power. So I'm actually going to factor out the negative and rewrite this in order of decreasing power. Not that that was necessary for the purpose of factoring, but it makes it a little bit easier for me to work with. Now I can quite clearly see, even though I can see it up here, this is a lot more comfortable. I can clearly see that this is a difference of squares. So square root of a squared is a, minus the square root of 25 is 5. And then I'll put a plus 5 as my second factor. Remember, I can't get rid of that negative in front. Whatever I factor out, that's got to stay there the whole way down. All right, z to the 6th minus 9. Now, this question is quite honestly meant to test and see if you really understand what it means to take the square root of a power. Because you can't take the square root of 6, but you're not taking the square root of 6. You're taking the square root of z to the 6th. And as soon as you put something in the exponent, the rule is a little different. Okay? What we're looking for, and I know we said this before, but I'll say it again here. What I'm looking for is this number divisible by 2? Okay, that's how I take the square root of a power, okay, by dividing its exponent by 2. Okay, I'm going to say that again. In order to take the square root of a power, you divide the exponent by 2. So that's z cubed, and I'll put the z cubed over here, and then the square root of 9, okay, that's obviously 3. And then I'll put a plus 3 over there. So there's my binomial conjugates here. This is where I would end here, because if I try to now take the square roots of these two terms here, I couldn't do anything with this one right here, but I could do something here possibly. But if I try to divide that by 2, I'm going to get z to the 3 halves, and I can't do much with that. So, and the square root of 3 is an irrational number. So that's it. This is as far as I'm going to be able to take that comfortably. Number 9. Okay, we've got 50m to the 4th minus 98m squared n squared. Okay, a lot going on there. Look at the coefficients here. in terms of what's common, really it's just a 2. But I do have m in both terms. It's to the 4th here and squared here, so I take out the smallest exponent, that'll be squared. And this leaves me with 25m squared in the first term, minus 49n squared. Okay. Well, now what I'm left over with is quite clearly a difference of squares, so 2m squared. Break this apart into two binomials. Square root of 25m squared will be 5m, minus the square root of 49n squared will be 7n. And then I write out the conjugate. Okay, now we're going to do a couple more, or 3 more. Whoops, move up here. Okay, this has the same sort of problem that I addressed before here. It's written in the wrong order here. I'm going to put this in standard form. And because that addition sign is in front of the x to the 16th, really this is just going to be a matter of changing the order. That's all I had to do. Now, can I take the square root of these two terms? Well, the square root of 81 is 9. That's fine. Can I take the square root of x to the 16? Yes, and I can do that because 16 is divisible by 2. So this becomes x to the 8th minus 9. Take the square root of both terms, x to the 8th plus 9. Now, before I go on to the next question here, take a look at what you're left over with. Take a look specifically at this first one. Can I take the square root of those two terms? Well, I can take the square root of 9 for sure. Can you take the square root of x to the 8th? Yes, because I can take that 8 and divide it by 2. So this becomes x to the 4th minus 3, x to the 4th plus 3. So x to the 8th minus 9 can be broken down into these two conjugates. But don't forget about this x to the 8th plus 9 over here that I can't do anything with. That's as simple as that's going to get. Now, I have to check. I mean, I was able to do this twice here. Check. Can I take the square root of, or sorry, can I factor this first term down? Two terms with a subtraction in between. Now, in spite of the fact that x to the 4th does have a nice square root, it would be x squared. 3 doesn't. And so because at least one of these two is not a perfect square, that's it. I'm done. I would stop looking at that. Here, okay, I got a fraction here. I don't want the fraction, so I'm going to factor that out first before I even try to do any kind of difference of squares here. Now, x squared over 4 divided by 1 over 4, essentially I'm just getting rid of that leading coefficient there, that 1/4. Negative 16 divided by 1/4 is going to be minus 64, or negative 64. Okay, not 4. I suspect there'd be a lot of people out there that would want to put a 4 there. Please bear in mind, okay, watch this. Let me put this up here. If this had been 4x squared minus 16, I would have taken out the 4 and gotten x squared minus 4, because I would divide both terms by 4. Now, if I change this first number to 1/4, then that second number there, in the binomial, can't be the same thing as 4. Like, factoring out a 4 and factoring out a 1/4 can't be the same thing. And the reason this becomes 64 is because I am not dividing into fourths. I'm dividing by 1/4. Okay? It's not 16 divided by 4. It's 16 divided by 1/4. That's what I'm doing. And when you divide by a fraction, you multiply by the reciprocal, and that's why I get 64 there. I keep saying that because I've witnessed a lot of people get this wrong. Okay, and I really want to help you guys get this correct here. So the 1/4 stays out front. And I can recognize that x squared minus 64, that is a difference of squares. So the square root of x squared is x, the square root of 64 is 8. And then I would write that as x plus 8. So there's my binomial conjugates. Okay, one more. 0.81 x squared minus 0.25 y squared here. Okay, what I would probably do here, because I've got decimals here in the question, part of me would be tempted to just leave those in there. However, this is really like 81 over 100 x squared minus 25 over 100 y squared. There is this common 1/100th to both terms here, so I would be very tempted to just yank that out here. And what that would leave me with here would be 81 x squared minus 25y squared. It just looks a little bit cleaner when I do that. And now I can recognize right away that I've got a difference of squares here. Can't get rid of the 100th, I got to keep that there, but now I've got the two terms, and this is going to be square root will be 9x minus, and then the square root would be 5y. And then I'll write the conjugate down by writing 9x plus 5y. Okay, and there you go.
And finally, we will take a look at factoring trinomials.
Right, so now we're going to look at factoring trinomials. Okay? And when you're dealing with trinomials that are the form, okay, where you've got ax squared plus bx plus c, but if we're looking specifically where the leading coefficient here is 1, then what we've got here is really what we're investigating here are the trailing coefficient over here, the constant here, and the coefficient of the linear term, the middle term there. And what we're looking for here is we're looking for two numbers whose product is going to be that last number and whose sum is going to be that middle one. Now the reason why that's the case here is because if you've got, let's say, let me zoom in here a little bit. Whoops, wrong way. If I gave you two binomials to multiply together, let's say x minus a, x minus b, and you multiplied those together, you would get x squared, then you'd get negative bx, negative ax plus ab. And so x squared would equal, and when I simplify this, I would get a plus b, x in the middle, plus ab. Notice that the final number there is the product of two values, and that middle coefficient is the sum of two values. Now granted, it might be negative, could be positive. That's what we got to figure out here. So that's how we're going to work this thing through. So we're looking for two numbers now whose product is going to be 24 and whose sum is going to be 14. This is the hard part of this problem. Okay, anytime we're dealing with factoring, it's always coming up with those numbers that's the difficult part. And you know, there's lots of different methods of factoring, but every one at some point requires us to figure out this. Now, it's you just run through factors of 24. Now, most of us jump immediately to 4 and 6, but 4 and 6 won't add to 14. So then you got to start thinking about other ones. 3 and 8 gets you 11. But 2 and 12 will get you 14. So that same pair of numbers here and here will actually add up to 14. And so now I know that this here is going to equal, now normally I would have written this underneath here, so let's just do it down here. This is going to equal x plus 2, x plus 12. And when you multiply that out, that will take you right back to there. Okay, now let's take a quick look at this m squared minus 15m plus 50. So I'm looking for two values whose product is 50, whose sum is going to be negative 15. Now notice the product here is positive, meaning that the two numbers I'm looking at here are either going to both be positive or both be negative. But because the sum is negative, I know that these two numbers must both be negative. And when I look at 50, immediately I think 25 and 2, but that's not going to give me 15. So then I'm thinking, okay, what other factors are there? And the other one that I jumped to really quickly is 5 and 10. And that's actually what I'm looking for. But specifically negative 5, negative 10. And again, because the leading coefficient here is 1, this is going to equal, I'm going to create these two binomials. It'll be m minus 5, m minus 10. Okay, and that's what you get when you factor that. Now the other form of this, okay, occurs when the leading coefficient isn't 1. Now in the past, if you've gone through other videos that I've put together here, you're going to see that I have strongly worked with decomposition as a method of factoring trinomials of this form here. And I've done that specifically because when we first look at that in Math 10, we start by looking at greatest common factors, and then we move to grouping, and then we move to trinomial factoring. And it's a very natural thing to do that, to use decomposition, because decomposition takes an expression like this that's got 3 terms in it and splits up that middle term, because we already know that that's the sum of two numbers. What we do is we find those two numbers and split that up into two values. That puts us into a place where we can use grouping, which is using common factoring. And so essentially the reason why I've used decomposition quite heavily here is because it's utilizing a tool that we introduced earlier on. Okay, and so that allows a lot of continuity in terms of the concepts that you're learning. It's just a very, very steady, nice, natural progression in terms of the material. Now that we're in Math 20 here and we're looking back and just trying to renew kind of our thinking here about factoring, one of the things that we want to do here is we want to try to improve your efficiency with this. Okay? So now hopefully you've done enough factoring in Math 10 that you do get a sense of how to do this. Now what I want to do is I want to help you with your efficiency here. What we're going to do is I'm going to show you how guess and check works. Because every bit of factoring you're going to do, except for very, very few questions here, but most of them can be done very, very quickly just by guessing and checking. But you got to be clever. Got to be clever about the guessing that you're doing. So first of all, bear in mind the way multiplication works here. If I've got ax plus b times, let's say, cx plus d, when I multiply that out here, okay, the first thing I do is multiply this term by this term, and that's going to get me acx squared. So these two terms, their product gives me that first number that I see. So when I look up here, I've got 2x squared. That means the first two numbers that I multiply together are going to have a product of 2x squared. Now in this case here, 2 is a great number here because it's prime. The only options I have here are going to be 2 and 1. So what we do is we place those two numbers up front, 2 and 1. Now, don't worry about what's going on in the middle here. Okay, it's going to be, well, I'll do it here. It's going to be ADX, it's going to be plus BCX, and then the final thing is going to be plus B times D. The final two numbers, their product is going to be that final value there, okay? Now in this case, once again, it's prime, so I'm going to, the only two options I have here are 3 and 1. So now here's the thing. These two numbers are going to show up in the back here. Now I've already plugged a 2 and a 1 in here. I get that from above here. So the question is it 3 and 1 or is it 1 and 3? I don't know. So what I have to do is I have to experiment with both of those. Okay? Because it was either 2x plus 3 times x plus 1 or 2x plus 1 times x plus 3. So let's just multiply this out real quick and just see what we get. 2x times x is going to be 2x squared. That's good. Plus 2x. And then I take the 3 plus 3x plus 1, 3 times 1 is going to be 3. When I add these two terms together, I'm getting 5. I'm getting 5. I'm supposed to be getting 7 as that middle term. This isn't it. This has got to be the answer. Now we're just going to verify that by multiplying that out. 2x times x is 2x squared. 2x times 3 is going to be 6x. 1 times x is 1x, 1 times 3 is 3. And when I add those together, that, yes, I'm getting my 7x in the middle there. So this is the answer that I'm looking for to factor that expression. Now, right now, me kind of explaining this, plotting through it, probably makes it look like guess and check isn't really all that quick of a method here. Let's go take a look at some examples and I'll show you. All right, so I'm going to run through a bunch of examples here, and my goal is to show you how quick and easy guess and check can be here. So let's take a quick look here. So I'm assuming that this can be broken down into two binomials. I see that my leading coefficient here is 5, and so I know, that being a prime, that it's got to be 5 and 1. So this would be 5x and x, has to be that. Now, when I look at 6 here, I've got a couple options here. It could be either 2 and 3 or 6 and 1. Now let's just think about that. If I put 2 or 3 here, okay, actually there's a couple ways that this could happen here. I could put the 2 and the 3 here. So if I did that, now think about this. 5 times 3 would get me 15. 2 times 1 is going to be 2. Okay, well, that actually works out pretty good because 15 minus 2 would get me 13. Now that would happen if this was negative 2. However, if I multiply negative 2 times 3, that's going to get me negative 6, and that's not what I have here. So that doesn't actually work the way I'd like it to. Now, that doesn't mean that the 2 and 3 are a bad choice. It maybe just means that I got to switch order. 5 times 2 is 10. Okay, so I get 10 there. 3 times 1 is 3. Now remember, those two middle terms, when I multiply the outer two together and the inner two together, when those are added together, that's my middle term. This is my OI, if you will. If you do this by using that expression FOIL, that middle term there is your OI. When I add those together, there's where my 13's coming from. So that's got to be it. So my choice here is 3 and 2, and they're both going to be positive. Please make sure that you put very clear operations inside the binomials, whether it's addition or subtraction. It should be really clear what it is you're doing. Anyway, then there we go. Let's take a look at the next one here. Okay, now before I jump in and start factoring this one, I notice that my coefficients here are 6, 8, and 2, and there is a common 2 to all three of those. If I take that out, I get 3x squared plus 4xy plus y squared. Okay, now I'm going to try factoring this here. So there'll be 2 out front here, and I'm going to assume that I've got the 2 binomials. Now, what's beautiful about this one, and this is where you're really going to see the speed of this pick up here, 3, okay, this leading coefficient can only be broken down into 3 and 1. So to get that 3x squared, this has to be 3x, this has to be x. It's the only way I can multiply those first two together to get this first term. This last term is y squared. Now importantly, 1y squared. Well, 1 can only be broken down into 1 and 1, so it's got to be y and y. Okay, and because this is addition and this is addition, remember addition back here in that last term means that these two terms here had the same sign, so they're either both positive or both negative. And if this middle term here is positive, this means that these are both positive. And that's it, I'm done. That has to be the right answer here. Now, just to double check though, let's check for that OI term. Remember, OI is that middle one here. So 3x times y is going to be 3xy. Y times x is xy. So this is 3xy plus xy. And yeah, I do get the 4xy. So that is the correct answer. Okay, I am able to get that middle term with these two factors. So I did it correct. Here, okay, I look at those three terms. There's nothing common to all three terms. Okay, so I don't have to take anything out. I'm going to assume that we can pull something out here. Now, 4, okay, 4 can be broken down typically into 2 and 2. So 2x and 2x, I'm going to assume that's my answer here. Now, the beautiful thing about 1 can only be broken down into 1 and 1. Now, because it's -1, one of these two is positive, one of them is negative here. And now take a look at this. Look at the way this is written out here. It doesn't really matter which one's positive, which one's negative, because they're both basically the same. Now, if I multiply this out, and remember, I'm checking the OI term. I already know that my first term, okay, my f, my first, will get me that 4x squared. My last two terms are going to get me that -1. I know that because I made it that way. I just got to check and see if the two middle terms are going to give me that -3x. 2x times -1 is -2x. And then positive 2x, and if I add those together, I'm getting 0, not -3. So actually, that doesn't work. But what that means is the numbers that I chose for my first expression, that's what the problem is. Okay, because 1 really can only be broken down into 1 and 1. I had no other choices there. So it really, what I got to look at is the 4. 4 broke down into 2 and 2, but it could also break down into 1 and 4. Now, so this could be 1 and 4. Now, when I multiply that out, I will get that 4x squared, and I'm still getting the -1 at the back here. Let's check and see if we can get that middle term. X times -1 is -x. 1 times 4x is going to be positive 4x. When you add those together, I'm getting positive 3. Ugh, I'm so close, but the sign is wrong. What that suggests to me is that I simply put those in the wrong position. It should have been up front here, 4x plus 1, x minus 1. And now if I multiply those out, I will get -4x when I multiply it by the -1, positive x, and there's where my -3x comes from. That's what the factoring should look like. Now I've written that out there quite a bit. The more you do this, the more comfortable you're going to get with this, the faster you're going to be able to do that kind of a check just in your head. And you'll be able to get to the answer quite a bit quicker. Okay, let's keep going here. 4x squared minus 23x plus 15. All right, there's nothing common to all three of those terms, so there's nothing to factor out to start off with. So I'm just going to break this down into my two binomials. Okay, 4 can be broken down in a couple of different ways. We've already seen that. So can 15. 15 can be 3 and 5, as factors, or it could be 1 and 15. I'm not entirely sure what it is. But I'm going to start with, when I break apart the 4, I'm going to assume it's 2 and 2, just to start off with. Okay, if I can't make that work, I'll try something else. And now 15. Now, bear in mind that 15 is positive here. This final product is positive, meaning that my two values here, whatever I plug in here, whatever I multiply together, have got to be the same sign, either both positive or both negative. Because this middle term is negative, they must both be negative. That's the only way I'm going to be able to introduce that negative in there. Now, 15 could be 5 and 3. Now, because it's 2x and 2x, it doesn't really matter where I plug things in. Let's just do it like that. So now let's just take a look here. And remember, what we're looking for here is are the middle terms here. So it's going to be the outer product and the inner product that I need to check. I already know I will get 4x squared there, and I will get positive 15 there, because I built those numbers to do that. But 2x times negative 3 is going to be negative 6x. Negative 5 times 2 is going to be negative 10. And those I can't combine those to get negative 23. That's not going to do it. Okay. Now, let's just check and see if I maybe screwed up with the 15 here. Maybe. Now, flipping the 5 and the 3 is not going to do anything because those terms are basically identical except for those last numbers there. So I'm assuming that 5 and the 3, that was incorrect. Let's try this. Maybe it was 15 and 1. Okay, who knows? 2 times negative 1 is negative 2. Negative 15 times the 2 is negative 30. Okay, well, that's not going to get me that negative 23 either. So what that means is that it was my first guess, thinking that 4 broke apart into 2 and 2. That was the problem. Okay, oops, I'll clean this right up here. So I just got to go back, and instead of 2 and 2, I got to make this really 4x and 1x. Okay? Now, once again, my reasoning before was correct. This has got to be negative. This has got to be negative. Now, let's try it again with the 5 and the 3. So 4x times negative 3 is going to be negative 12. And then negative 5 times 1 will be negative 5. Okay, negative 12, negative 5, that's negative 17. That's not negative 23. Now, this time, though, those first two terms are different, so I can switch them. 4x times negative 5 is negative 20. That's a good sign. Negative 3 times 1 is going to be negative 3. And there's my negative 23. That's the middle term that I'm looking for. That's the factoring that I'm looking for. Okay? Now, that may look like that is a slow process, particularly based on this question, but I'll let you know something. As soon as I started writing stuff down, as soon as I wrote down the 2 and the 2, I knew that wasn't going to work. Okay? Because this is just a comfort level for me. I could see that 20 in there. I knew that this had to be the 4 times that 5 to get that factor of 20 to pop out. So the more comfortable you get with this, the more often you do this, the faster you're going to see what those factors have to be. But we got to get you there first, and I need you to sort of see the pattern of thinking. And I got to kind of fumble my way through this first so that you kind of see that happen, and then you'll get quicker and quicker at it. Take a look at number 5 here. Okay, I don't like the way number 5 is written. It's not pretty. I want that in standard form. So the very first thing I'm going to do is I'm just going to change the way the question looks just by changing the order. Okay, that looks better. Now, there's nothing common to all three terms. So I'm going to throw down my 2 parentheses there. 6. Okay, 6 can break down into 2 and 3 or 6 and 1. I don't know what it's supposed to be. So I'm going to assume right now 2 and 3. I got to start somewhere. But negative 5, these last two values here have to have a product of negative 5. Now, because it's negative, one of them's negative, one of them's positive. Okay? And because that middle term here is positive, that means however I break apart that 5, the larger product has to be the positive one. So I'll show you what I mean by that. So if 5 is going to be 1 and 5, now just watch this. 2 times 5 is 10, 1 times 3 is 3. I want the larger product to be positive, so I want this to be positive 5. So 2 times 5 is 10, and I'm going to put the negative here. Negative 1 times 3 is going to be negative 3, so this will be 10 minus 3. And hey, there it is. Actually, that jumped right out at me. That's the correct answer, because 10 minus 3 is going to get me the 7 there. Okay? And that's that's how you want to think that thing through. If this was negative and this middle term was negative, that would mean that the larger product was the negative one. Okay, because when I put the negative and the positive together, the positive number is not big enough to get rid of all of the negative value there. A little bit more questions like that, and you'll start to really get the sense of how that works. Question 6. Okay, first of all, let's clean it up. Let's take out what's common there. There's that common 3. And I'm left with x squared minus xy minus 2y squared. All right, now I love the way that looks right now. Okay, because 1, remember, I already am assuming that this can be broken down into two binomials. That x squared there, that can only be broken down into x squared, sorry, x and x. Negative 2y squared, that 2 can only be broken down into 2 and 1. So this has got to be 2 and y. Okay, 2y and y. Now here we go. This product here is negative, meaning that one of these two is negative, one of them is positive. And because the middle term is also negative, that means the larger value must be the negative one. So this one's got the 2 on it. So when I multiply x by y, multiply 2y by x, the 2y by x is going to be the larger one. This has to be the negative. This has to be the positive one. Now let's just double check. X times y will give me positive xy. Negative 2y times x will be negative 2xy. I'll just write that in the correct order. And yeah, when you add those together, you are going to get this negative xy term there. So there we go. That's correct. All right. Next. Well, you knew this had to happen at some point during this question here. The fraction. Okay, so the very first thing we're going to want to do here is divide out that denominator. Take that out. Now, remember, I am going to be dividing out 1/4. I'm not going to be dividing everything by 4. I'm dividing out 1/4. Over here, to move the 3 out, I divided by 3. Whatever that number is out front there, okay, in this case right here, that was what was common. I divided that out. Here, I'm going to divide out the 1/4. Now, out of the first term, that's straightforward. That's going to get me x squared. That middle value here, I start off with negative 1, and I'm going to divide out 1/4. Well, that's the same as negative 1 multiplied by 4 over 1. So this middle term here becomes negative 4. Then I get this negative 3. Well, I'm dividing again by 1/4. I'm not dividing in quarters. I'm dividing by a quarter. So negative 3 divided by 1/4 will be negative 3 multiplied by 4 over 1, multiplied by the reciprocal. And I'm going to get negative 12 there. Okay, so now, my little guess and check here, x squared, that's nice. That's going to be broken apart into x and x. That's easy. Okay, negative 12. Okay, negative 12 can be broken into actually factors a few different ways. 1 and 12, 2 and 6, 3 and 4. It's negative, so one of them is going to be negative, one's got to be positive, and because the middle term is negative, that means the larger one has to be the negative one. Now, 1 and 12, those factors here won't get you the 4 in the middle when you multiply those out here. 3 and 4 won't either. 3 and 4, when you add those together, are either going to get you like a 1 or a negative 1, depending on where the negative is here. This has got to be 6 and 2. Whoops. Okay, 6 and 2. And like I said before, one of these has to be negative because of the negative 12 there. And because this term here is negative, it's the larger one. So it's got to be negative 6 and positive 2. Let's just double check that. X times 2 is going to be 2x. Negative 6 times x is negative 6x. And yeah, when you add those together, you're going to get the negative 4. Now, just to remind you what I'm doing here when I check this, because there's been a few questions before I've said this. Remember, x times x gets you that first term. Negative 6 times 2 gets you the last term. Those are the straightforward ones here. When you take that outer two terms and then the inner two terms, multiply those together, and add them, that's where you're getting that middle term there. And that's the one that we got to check. I already know that x times x will get me x squared, that negative 6 times 2 will get me negative 12. I chose those on purpose to do that. I'm just not sure if I'm getting that middle term out the way I want it. And that's what I'm checking when I do this down here. Okay, another question with a fraction. This time I'm going to divide out the 1/2 x squared. Now, here we go. The leading coefficient rate, sorry, not the leading coefficient, but the coefficient of the x here is negative 1. and I am going to divide out 1/2. I'm not dividing in half, I'm dividing by half. So that's -1 multiplied by the reciprocal, so we're going to get -2. And then my constant at the back here is -4. Again, I'm going to be dividing by half, so -4 multiplied by the reciprocal, and I'm going to get -8 back there. All right, now I'm going to break this into two binomials. X squared breaks apart into x and x, so it's really just the -8 that I got to play with. Okay, that product there is negative, meaning that the two values here are going to have different signs, and because the middle term here is negative, I know that the larger is going to be the -1. Fortunately, 8 only breaks up into a couple pairs here, 2 and 4 and 1 and 8. But I can see right now, even having just said those, that the answer's got to be 2 and 4. Because, and remember, I'm looking for a -2 there. I want the larger value to be negative, the smaller one to be positive. When I multiply those out, I will get -4x, middle term +2x, and when you add those together, that's where that -2 is coming from. So yeah, there we go. Okay, over here, that's an interesting question, because the fractions or the fraction really is in the other two terms here. But notice it's still the denominator that I want to yank out. In the previous two questions here, I took out the quarter. Here I took out the half. Now, really, the one here was kind of irrelevant. Even if this had been 5/4, 7/2, I would still have just taken out a quarter, still have just taken out a half. It doesn't really matter what the numerator is. I'm taking out the denominator. So here, notice that I've got the 5/2. I don't really care about that. The 3/2, I don't really care. What I'm going to take out here is the denominator. If these two denominators were different, I would take out the common denominator. It's the denominator that's the problem here, not the numerator, just the denominator. With the previous questions that we've done, that's not clear. So that's why a question like this one here is important. Now, the coefficient here is 1. And remember, I'm dividing by 1/2, which means I'm going to multiply by 2/1, which means in front of the x squared, I will be left with 2. Now, these last two, these are a little bit easier. The coefficient here is -5/2. If you divide by 1/2, that's -5/2 multiplied by 2/1. The 2's will cancel, and so I'm just going to be left with the numerator. And the very same will happen with that constant. I'm just going to be left with the numerator. And so now, from here, I'm guessing two binomials here. 2x squared can only be broken apart into 2x and x. That's the beautiful thing about having a prime number there. 3 can only be broken apart into 3 and 1. Again, a prime number. But here's the trick. This is negative. So I know that the product is going to be negative, which means one of those factors is positive, one of the factors is negative. The larger has to be the negative one because the sum inside the middle here, okay, that's negative. So the question is, how am I breaking this apart? Is it 3 and 1, or is it 1 and 3? Well, 2 times 1 is 2. 3 times 1 is 3. Now, even if I make the larger one negative, when I add those together, I'm still not going to get the -5. Remember, one of these is negative, one of them's got to be positive. And so that didn't work. Okay. Fortunately, though, that's only one of two possible guesses. It's got to be +1 minus 3 then. That's the only other possibility. 2x times -3, there's my -6. 1 times x is 1x, and when you add those together, you are getting the -5. So there's your answer. Okay, just got a few more here. Question 10. Okay, well, I got a bit that's common here. For sure, I've got a factor of 3 common to all three of those. And actually, I've got an x common to all three of those. So I'm going to pull that out. That's going to leave me with 2x squared plus 11x plus 15 at the end there. All right. 3x, I'm going to assume this can be broken down into two binomials. And I love the fact that that's 2x squared. That's got to be 2x and x. Don't even worry about the 11 for right now. Look at the 15. So 15 can be broken down a couple of different ways. Notice that this is positive 15, meaning that whatever those two numbers are right there, they've got to be the same sign. But because this is positive 11x in the middle, these two have to be positive. Now, I don't know, I'm guessing that this is going to be 3 and 5. Now let's just double check that. 2 times 5 is going to be 10x. That's good. 3 times x is 3x. Okay, well that sum there does not get you 11. That gets you 13. So that can't be the way that works. That doesn't mean 3 and 5 are wrong. It just might mean that my order is wrong. So let's try it like this. 2x times 3 is going to be 6x. Yeah, here we go. 5 times x is going to be 5x. And yeah, when you add those together, you do get the 11. So this is the answer that we're looking for there. 3x times 2x plus 5 times x plus 3. Good. Here we go, 11. Okay, 9a squared minus 24ab plus 16b squared. Okay, well there's nothing common to all three terms. There's nothing I can factor out. I do, however, have some options here. Okay, now, but when I first glance at this, I can see right away that, okay, 9a squared, now 9 can be broken down into factors a couple of different ways, but a very natural one is 3 and 3. 16 also has a very natural breaking here, 4 and 4. When you see perfect squares at the beginning and the end, one of the things you should try doing here is checking to see if it's the square roots here. Now, that last term there is positive, meaning that my two factors here must both have the same sign, and because the middle one here is negative, they've both got to be negative. Now, I'd be very pleased if this worked. Let's just check the outer and the inner products. So 3a times negative 4b is negative 12ab. Negative 4b times 3a is negative 12ab. Yeah, and when you add those together, you do get that negative 24ab. So there we go. So this question actually could have been written as 3a minus 4b squared, because there was two of them that worked. Always look for that pattern when you see that at the beginning and the end there. That might not have worked, by the way, but when you do see the squares at the front and the back there, there's a good chance it will work. All right, question 12. Question 12 has got something with it that I don't like. I don't like seeing a negative up front. It makes things more complicated. It's a little bit harder to kind of noodle your way through it. Factor out that negative. Now, that is going to change the sign of every other term, but you know what? That's a small price to pay. Those negatives I can deal with. The one in the up front, that is more difficult to deal with here. I'm going to assume that my remaining trinomial can be broken down quite nicely. I'm going to assume, notice because I've got this perfect square up front here, I'm going to assume that that's 2x and 2x. I don't know that that's true, but it could be. The 1 here is going to break apart into 1 and 1, and because it's negative, okay, one of these is going to be positive, one's going to be negative. Because the middle term is negative, that means the larger one's going to be negative. But as soon as I say that, I notice my problem. When I multiply out those terms, they're going to be the same size. That doesn't work. And the problem has got to be my 2x, okay? Because 1 can only be broken apart into 1 and 1. It has to be the 4 here. So that's got to be 4x and x. That's the only way I'm going to get, I'm actually going to get a larger product and a smaller product. So 4x times 1 is going to give me 4. 1 times x will get me x. I need the larger one to be negative, so I got to make this 4 times negative 1, positive 1 times x, and there we go. That'll get me negative 4x plus x. That sum is negative 3. That's the answer that I'm looking for. Okay, couple more. More fractions. Okay, more fractions. So in this case, the denominator is the same. I'm going to take out the 1/3. And actually taking it out of the first two terms is really just going to leave me with the numerators here. I hope we've done enough examples like this so that you could see right away that this number here is going to be negative 12. If not, bear in mind that it's the negative 4 here, and because I'm factoring out a 1/3, I'm going to divide that by 1/3. I'm not dividing it in thirds, I'm dividing it by a third, meaning I have to multiply by the reciprocal to do that correctly. And negative 4 times 3 is going to get me negative 12. So 1/3 is out front here. I will assume that this can be broken down into two binomials. X squared really can only be broken down as x and x. Negative 12, now when I see 12, I immediately think 4 and 3. Because this is negative, one of those has to be positive, one of them has to be negative. Because the middle term is negative, that means the larger of the two has to be the negative one. And so I'm still thinking 4 and 3. Negative 3, 4, positive 3. And actually, when you multiply those out, you will get 3x minus 4x. And yeah, there it is right there. I'm getting that negative 1. So that's the answer. And now finally, 5x squared minus 21x plus 4. There's nothing common to those three terms, so I'm just going to jump right in. And 5x can only be broken apart as 5x and x there. Okay, now 4, perfect square, I am assuming 2 and 2. I don't know that for sure. It could be 4 and 1. We've seen that already in the past here. But I notice that this is positive, so whatever numbers these two end up being, they're either both positive or both negative. And because this thing right here is negative, that means they've both got to be negative here. Now let's just double check this. 5x times negative 2 is negative 10x. Negative 2x times x is negative 2x. Okay, well that does not sum to negative 21. So I know it's got to be the 4 that I did wrong here. Now, it's got to be either 1 and 4 or 4 and 1. Now, 1 and 4, if I try to expand that out, I will get 5 times negative 4, negative 20. X, and the negative 1 times x is negative, and there is the one that I'm looking for. Negative 20 and negative 1 gets me the negative 21. So that's the answer that I'm looking for. Okay. Yeah, I know if you're following through my work here that this might not look like at this point the fastest method here, but I guarantee you the more you practice just guessing and checking, the faster you will get with this, the more efficient this method gets as you go along.